Let's talk about how to find the gradient of a function of three variables. The definition of a gradient states that given a function of three variables, and given that the partial derivative with respect to each variable exists, we are able to find a vector that points in the direction of the greatest increase of a function. In other words, this vector describes the rate of change of the function in a particular direction. We can write the gradient as either del f of x, y, z or grad f of x, y, z. In this problem, we want to find the gradient of the given function. Recall from the definition that our first criterion is that the partial derivatives with respect to x, y, and z must exist. So, we'll first find the partial derivative of f with respect to each variable. First, we'll take the partial derivative with respect to x. Remember, this means that the variables y and z are not affected by taking the derivative and are considered to be constants or static values. So we have the partial derivative of f with respect to x equals 2z plus 3x squared y. So we can see here that the partial derivative with respect to x does exist. Let's take the partial derivative with respect to y. This gives us negative 6y minus 6z squared plus x cubed. Therefore, we know that the partial derivative with respect to y exists. Now we'll take the partial derivative with respect to z. When we take the partial derivative with respect to z, we get 2x minus 12yz. Recall that the equation for the gradient looks like this. Since we have all three partial derivatives, we can set up our gradient by plugging in each partial derivative. This gives us the quantity 2z plus 3x squared y times I plus the quantity negative 6y minus 6z squared plus x cubed times j plus the quantity 2x minus 12yz times k. This gives us the gradient of the function.